So, if you're someone who works in technical computing, you definitely know the drill. You've got one tool for your heavy math, another for wrangling all your data, and maybe even a third one just for coding. It feels like a constant juggling act, right? Well, today, we're going to dive into an all-in-one environment called Nelson that promises to put an end to all that chaos.
It's a super familiar headache, isn't it? You're constantly switching between what feels like a powerful calculator, a database manager, and your coding environment, just trying to get them all to talk to each other. It's not just inefficient, it's honestly pretty frustrating. So what if there was just one integrated environment that could handle it all?
And that right there is the core promise of Nelson. It's a single, high-performance platform that's been designed from the ground up so you can move seamlessly from really complex math to sophisticated data analysis and even to building full applications, all from one command center.
Okay, so let's get into the weeds a bit, starting with the very heart of Nelson, its raw computational power. I mean, any serious technical environment has to be built on a rock-solid mathematical foundation, and Nelson is absolutely no exception.
Just look at the sheer breadth of what's available right out of the box. And we're not just talking about the basics. You've got deep linear algebra functions, all the standard data analysis tools you'd expect, and even a high-performance, fast Fourier transform engine for signal processing. This thing isn't just a calculator, it's a really comprehensive mathematical toolkit, ready for some serious research.
Now, here's where you start to see the level of control you really get. In technical computing, precision is everything. Nelson lets you be super explicit about your numeric types just by using a simple suffix. That means you can define a number as a 64-bit integer or a single precision float. So why does this matter? Well, it helps prevent those subtle, hard-to-find errors, and it optimizes your memory usage, which is absolutely critical when you're doing large-scale computations.
But, powerful computation is only half the battle. Raw numbers don't mean a whole lot until you can actually organize them. So let's take a look at how Nelson handles data structures, because this is where it really starts to shine. Let's be honest, real-world data is messy. It's rarely just a simple grid of numbers, right? It's usually a mix of text, values, and all different types of information that somehow need to work together. And to handle all that mess, Nelson gives you this awesome, flexible toolkit of data structures. Need something that works like a spreadsheet with mixed data types? You can use a table. Need to store completely different things together, like, say, an image and its metadata? That's exactly what cells are for. It's this flexibility that lets you model complex, real-world information accurately. So here's the really crucial part. It's how these structures work with the math engine. Instead of writing these complicated loops to go through a dataset row by painful row, you can just apply a function, like sine or abs, to the entire table at once. This makes your code so much cleaner, way more intuitive, and much, much faster. All right, so you've crunched the numbers, you've organized the data. What's the next logical step? Well, it's to understand it visually, and maybe even build an interactive tool around it. Let's see how Nelson tackles that.
First things first, turning all that raw data into something you can actually see and interpret. This is where built-in plotting comes into play. Nelson comes packed with built-in plotting tools that let you visualize your data with just a single command. So whether you need a simple bar chart or a complex 3D surface, you don't have to export your data to some other program. It's this tight integration that really streamlines the whole workflow, taking you from raw analysis to clear insight in just seconds.
But what if you want to go beyond just a static plot? What if you need to build a simple tool or a custom graphical user interface for other people to use? Yep, Nelson has you covered here too. For simple interactions, you can pop up quick dialog boxes for messages or questions. But for more advanced needs, it actually integrates with the powerful QML engine. What that means is you can build sophisticated, custom graphical applications right on top of your computational code without ever having to switch frameworks. A modern tool really can't exist in a bubble. Its real power often comes from how well it connects with the outside world. Other languages, other services, and other systems. And Nelson is designed to be a central hub for all of that.
And this is really about making Nelson not just a tool, but the central hub of your entire technical workflow, connecting all the other pieces that you rely on day to day.
The level of connectivity here is just key. Nelson can automatically use your multi-core processor to speed up your work. It has a built-in Python engine, so you can pull in your favorite Python libraries without any hassle at all. Need to integrate with some legacy C code? It can do that. Need to pull data from a web service? It has built-in tools for that too. It's really designed to fit into your existing world, not force you into a brand new one.
So after seeing all of that, let's kind of bring it all together. What is Nelson at its core? And more importantly, could it be the right tool for your technical challenges?
It really just boils down to these 4 pillars. A powerful computational engine for all the heavy lifting. Advanced data structures for managing real-world information. Integrated visualization and GUI tools so you can see and interact with your results. And finally, that extensive connectivity to make it a central part of your entire workflow.
And that brings us to the final, and maybe the most important question. With a tool that brings all of this power together in one seamless environment, what's the first big problem that you would want to solve? Thanks for joining this explainer.